In this part of the video, we're going to look at an example where we are asked to evaluate the definite integral, the integral from 3 to 4 of 3x squared minus 2 raised to the fourth times x dx. Okay, so this is a definite integral, and anytime I want to evaluate a definite integral, the first thing I do is ignore the bounds and look at the indefinite integral. So I have the integral of 3x squared minus 2 raised to the fourth times x dx. And what I notice about this integral is that we have fancy stuff raised to a power. The 3x squared minus 2 is all being raised to the fourth power. So there's a really good chance that a u substitution is going to come into play here. So I will start by choosing my value for u. And I choose my value for u by looking at the most complicated part and then choosing the inside. So in this case, I'm going to choose my u to be 3x squared minus 2. And I'm going to circle that because it'll be important. And my steps for a u substitution are to, off to the side here, take the derivative. So the derivative of u is du over dx. And the derivative of 3x squared minus 2 is 6x. Okay, once I have du over dx equals 6x, then I want to solve for dx. So step 1 of solving for dx is to multiply both sides by dx. Brings dx out of the denominator, and then I divide by 6x. And that's going to leave me with dx is equal to du over 6x, and that's important, so I'm going to circle it. Okay, so back to our indefinite integral. Our indefinite integral will now be the integral of, we're going to make our substitutions, so instead of 3x squared minus 2 to the fourth, we will have u to the fourth times x, and instead of dx, I have du over 6x. Okay. So looking at what I have now, I'm kind of happy because I see that I have an x in the numerator and a 6x in the denominator, so the x's will cancel, and that leaves me with the integral of u to the fourth du over 6. And I want to clean this up, and the one thing that I want to do to clean this up is bring that 6 to the front. Now the 6 was in the denominator, so it's got to stay there. So I have 1/6 u to the fourth du. Great. I have changed my integral entirely in terms of the variable u. There are no more x's, and I've cleaned this thing up. So now I'm ready to take my antiderivative. And remember, you always want to remember that this step has to happen. You do all that work. Oops, I did not spell that right. Derivative. You do all the work to turn this thing into u's, make sure you take the antiderivative. Okay, so to take the antiderivative, I add 1 to the power, so I have u to the fifth, and I divide the number in front by the new power. So I have 1/6 over 5, u to the fifth, plus c. Cleaning up that fraction in the front, 1/6 divided by 5 is 1 over 30, and you can check that in your graphing calculator, and you can even use the fraction button in there, and that will give you 1 over 30. So we have 1 over 30 u to the fifth plus c, and my last step in the u substitution is to replace the u, and our u value was 3x squared minus 2, so I have 1 over 30 times 3x squared minus 2 raised to the fifth, I don't want to forget that power there, plus c. Okay, so all of that work was to find the antiderivative of that function in the middle. So this 1 over 30 times 3x squared minus 2 to the fifth, that is our capital F of x. And now we want to plug into that capital F of x, we want to plug in our top bound, which is 4, so we have capital f of 4, and so we have capital F of 4 is 1 over 30 times 3 times 4 squared minus 2 raised to the 5th power. And then if I plug that into my calculator, and you should check that you get the same thing, but what I get is 6865432.5. So if I throw in some commas, that's 6,865,432.5. And our capital F of 3, that is our bottom bound. The 3 is at the bottom of the long stretched out S. We plug in 3 for x, and so we have 1 over 30 times 3x squared, so that's 3 times 3 squared minus 2 raised to the 5th power. And when I type that into my calculator, what I get out is 325520.8. I would encourage you to double check that you get the same values when you type this into your calculator. Once I write down the number, put in some commas, it looks like capital F of 3 is 325,520.8. Okay, so to evaluate the definite integral, we first find our antiderivative. There it is, there's our antiderivative. Then we calculate f of b, so that's our antiderivative is capital F of x. We calculate f of b and f of a, and now we subtract those two values. So we have capital F of 4 minus capital F of 3 will be 6,865,432.5 minus capital F of 3, which is 325,520.8, and when you subtract them, you should get 6539911.7, and if I throw in the commas, I end up with 6,539,911.7. So our answer is approximately 6.5 million. So if we were to graph the function 3x squared minus 2 raised to the 4th times x, and we drew the area under that function between x values of 3 and 4, the area would be 6.5 million square units. So we may want to check our answer with our graphing calculator. Again, if you are asked to evaluate an integral by hand, then you'll want to do the method that we just talked about, but it's nice to be able to check your answer. And so to check our answer with our TI-84 graphing calculators, what you can do is you can graph the function using the y equals. And so some things that I would want to do are, I know that I care about x values from 3 to 4, so I might make those my x minimum and x maximum. And then to get a nice picture, I would use Zoom Fit. And that's going to give me this. So that's going to give me this graph. And what I notice is if I were to go back and check my window again, I would notice that the y values are pretty stinking huge. I mean, the lowest y value is around 1 million, and the top y value is around 18 million. So this is a really large graph. Okay, so the next thing, once we have the graph, is that we now want to hit second and then trace on the calculator. And when you do that, you will get a menu, and item number 7 on that menu is the integral of f of x dx, so you want to hit enter. And the calculator is going to ask you for a lower bound, and that lower bound will be the number at the bottom of the integral sign, so that's the 3. Type in the x equals 3. Your calculator will ask you for an upper bound, and type in the 4. And then when you hit enter, then your graphing calculator will shade the region that we're talking about and tell you that the integral of f of x dx is 6,539,911.7, which was our answer that we came up with. And on the newer graphing calculators, this 3 to 4 comes up, which is really nice. But if you have an older graphing calculator, it won't tell you that interval. That's your bounds from 3 up to 4 for the x values. Okay, that makes me happy. All right, so the next part is that if you want to check it on your graphing calculator without actually graphing the function, here's another alternative. So on your graphing calculator, look for the Math button, and there it is on the left-hand side. And when you hit the Math button, you'll see a menu show up, and number 9 on that is fnint. That's function, fn for function, int for integration. Hit that button, and on new calculators, your screen will show up with an integral sign and some parentheses where you're going to put the function in the middle, and then a D with a blank at the end. And so you can fill in the information just like it looks the way that you would write it. And so once you type that in and hit enter, you get the same value that we would expect. Now, for me, on the emulator on my computer, which is where I'm getting these screenshots from, this is the newer version of the calculator. When I pick up my handheld TI-84 Plus Silver Edition, which is, I have no idea how many years old, I don't get that nice interface of the integral sign. And so on my calculator, which is a bit older, I will need to use, I start out the same, I hit the Math button, I choose fnint, and then fnint will show up with an open parenthesis. The first thing I want to do is fill in the function, and then a comma, and there's a comma button that shows up right about here on your calculator, right above the 7. And then the x, which I can get from the variable key, the same x that I use when I'm graphing. And then another comma, and then my lower bound, a comma, and then my upper bound, and then close the parentheses. For our particular example, that would look like fnint of 3x squared minus 2 raised to the 4th, comma x, comma 3, comma 4, and then you hit enter, and it should give you the same final answer. Okay, so all that is saying is, if you want to check your answer, there are a variety of ways to do so on your calculator, but also be sure that you show your antiderivative and plug in your values and do these things by hand as well. All right, thanks for listening.